Measures of center, 3.1, 3.2 measures of variability, and 3.3 measures of position. Measures of center, this is chapter 3 is actually one of my favorite chapters. 3.1 measures of center. This is the most commonly used statistical formulas. Wait. Jared, that is okay. Jared asks if TI-83 is good. Yes, it is. Is it the black one or no? Jared. Yeah. There are only two shortcut problems that you won't be able to. I think there's no shortcut for that, but that's only two. So, but the rest, so far, TI-83 is good. Okay. All right. So again, measures of center. These are the objectives. Compute the mean of the data set, the median, the properties of mean and median, then find the mode of the data set, approximate the mean with the group data, and then compute the weighted mean. I'm sure some of you heard about mean, median, and mode, right?
Yep.
So we will start with the mean. So the mean of a data set is a measure of center. If we imagine each data value to be weight, then the mean is the point at which the data set balances. So just like an example here, these are the 5 statistics scores, let's say from test 1, 68, 78, 83, 85, and 82. To balance all these 5 numbers, look at this is like a balancing something. And to balance all these scores, you need to get the mean of these 5 scores. And the mean is 81.2. Now, how do we get that 81.2? So these are some notations for the mean, population versus sample. So if you please copy this. Population mean, we're going to use the symbol mu that consists of an entire collection of individuals about which information is sought. And a sample, X bar, consists of a smaller group drawn from the population. So population mean is mu. And this one, sample mean is X bar. And the formulas for those two, sample mean is summation of xi over n. Summation symbol meaning is represents the sum of the numbers. Let's say the numbers from x1 up to xn. So x1 plus x2 plus x3 up to xn. That's the summation of all the numbers divided by the total n, which is n. Then the population mean is summation of x all over the capital N. So let's go back to the same example. So for let's say during a semester, a student took 5 exams, and the population exam scores is 78, 83, 92, 68, and 85. So to find the mean, so you know the formula summation of xi over n. So summation, you need to get the sum of all these 5 numbers, 78 plus 83 plus 92 plus 68 plus 85 divided by 5. So because you have 5 exam scores here, so that's why n is equal to 5. So when you divide it by 5, 406 divided by 5 is 81.2. So note that the mean is rounded to 1 more decimal place than the original data. This is generally considered a good practice. So you should always round of your final answer to one more decimal place than the original given. Any questions so far? So mean is meaning finding the average. So I'm sure you are aware or familiar with that. All right, next is the median. So this is another measure of center. The median is a number that splits the data in half so that the half that the data values are less than the median and the half of the data values are greater than the median. So there are two cases here, and take note of this. If n is odd number, then that's the easiest way to get the median. All you have to do is get the center, and that is the median. If n is even, all you have to do now is you will have two middle numbers, and those two middle numbers, you have to take the average of these two. So meaning you add these two numbers divided by 2. But before you do all this, you have to make sure that you arrange this in order. So just like an example here, using the same exam scores, 78, 83, 92, 68, and 85, find the median. So I mentioned earlier that you have to arrange first in order. So in increasing order, so the lowest exam score is 68, then 78, 83, 85, and 92. So there are 5 numbers here, and the middle number is 83. So that's why this is the median. So don't forget, arrange it in order. Then the middle, if n is an odd number, 1, 2, 3, 4, 5, the middle number is the median. Let's have another set of example here. 8 patients undergo a new surgical procedure, and the number of days spent in recovery for each is as follows. Find the median number of days in recovery. So 1, 2, 3, 4, 5, 6, 7, 8. So that's why n is equal to 8. Computing for the median, arrange first in increasing order. Lowest number is 12, next 13, next 13, next 15, then 19, then 20, then 21, and then 27. 1, 2, 3, 4, 5, 6, 7, 8. And where's the middle here?
15 and 19.
15 and 19. There are 3 numbers to the left, 3 numbers to the right. So we have to take the average of 15 and 19. So that is 15 plus 19 divided by 2 is equal to
12.
34 over 2 is
17.
17. So the median is 17. Very good.
Yeah.
Easy, right?
Yes.
So don't forget to arrange it in order, increasing order. All right, next objective here. Compare the properties of mean and median. So I want you to copy this. Statistic is resistant if its value is not affected much by the extreme values. That is, if it's a very, very small number or very large number in a data set. The median is resistant but the mean is not. So again, take note of this. Copy the definition of resistant. A statistic is resistant if its value is not affected much by extreme values. So for example here, 5 families have annual incomes of 25,000. That's the first one. Next, 31,000, 34,000, 44, and 56,000. One family whose income is 25,000 wins $1 million lottery, so their income increases to 1,025,000. So at first, before the lottery, we can compute for the mean and median. So mean is add these 5 numbers, 1, 2, 3, 4, 5, and divided by 5, and you will get 38,000. The next, for the median, arrange the 5 numbers in order, and this is actually in order, so the middle is 34,000. After the lottery win, meaning 1 instead of 25 is 1,025,000. So meaning if you add these 31,000, 34,000, 44,000, and 56,000 divided by 5, you will get 238,000. And the median, if you arrange these 5 numbers in order, this time the middle, the center is 44,000. So as you can see here, the extreme value of 1,025,000 influences the mean quite a lot, increasing it from 38,000. Look at the mean here before lottery win, 38,000, and then after is now 238,000. When you compare the median from 34,000 and 44,000, so that's why the median is considered as a resistant. Okay, so don't forget, again, that's why I asked you to copy the definition of resistant, not affected much by the extreme values. So median is not affected much, even though there's a big income here of 1,025,000. All right, so the mean, median, and the shape of the data set. Okay, the mean and the median measure the center of data set in different ways. So look at these 3 different curves here. The mean, it is symmetric if the mean and the median are equal. So you see here a bell-shaped curve. So if the mean and median are equal, then it's going to look like this. So that is what you call symmetric. Skewed to the right if the mean is greater than the median, just like this, and it's skewed to the left if the mean is less than the median. So I want you to copy all 3: symmetric, skewed to the right, and skewed to the left. All right. Next one, and the easiest among the 3, find the mode of the data set. The mode is the most frequent. if two or more values are tied to the most frequent, then they're considered to be modes. If the values all have the same frequency, then the data set has no mode. So an example here, 10 students were asked how many siblings they had, and the results arranged in order 0, 1, 1, 1, 2, 2, 3, 3, 6. Find the mode of this data set. So the most frequent is
1.
1. So there are 4 ones, there are only 2 twos and 2 threes, the rest ones. So the mode is 1. The mode is sometimes classified as a measure of center. However, this isn't really accurate. The mode can be the largest value in a data set, just like an example here, or the smallest on anywhere in between. So take note of this, means and medians can be computed only for quantitative data. The mode, on the other hand, can be computed for both quantitative and qualitative data, because we know that mode is just taking the most frequent. So just like an example here, the following is a list of makes of all the cars rented by an automobile rental company on a particular day. Which make of car is the mode? So how many different cars do we see here? We see Honda, Ford, Chevrolet, and Toyota. And
Dodge.
the most frequent is?
Is it Toyota?
Toyota. So how many do you see? 1, 2, 3, is it 5?
There's 6.
6? 1, 2, 3, yeah, 6. Okay. So Toyota appears the most frequently, so the mode is Toyota. Okay, so next one, approximate the mean using group data. And these are some of the steps. Step 1, compute for the midpoint. You learned that last chapter. Do you remember how to get the midpoint? Oops, sorry. Midpoint is the x. How do we solve for the midpoint? Taking the average of the lower class limit and the lower limit of the next larger class. Just like LL1 plus LL2 divided by 2. For each class, I multiply the class midpoint by the class frequency. So after you have a column for x, so let's say class limits, then you have frequency. Then you know how to solve for the class midpoints, just like what we did last time. And then next is multiply f and x, the frequency and x. So multiply these two numbers. And then all you have to do is just add the numbers here and then divide by your total n. So that's how you solve for the mean. So like what I said again, are the class limits. This is the frequency. All you have to do is add the class midpoint class midpoints x, next column, and then f of fx, multiply the numbers. So let's try this. What's the first class midpoint?
25.
So 0 plus 50 divided by 2 is equal to 25. Very good. And what is the class width here?
50.
50. So all you have to do is just add 50 here. So 25 plus 50 plus 50 plus 50 and plus 50. Okay. Then fx is multiplying f and your x. So it's 10 times 50, 250 here. And then 5 times 75 is it 375?
375.
Yeah, and so on and so forth. And we have that data on the next slide. So I'm just showing you how to do it, okay? So you have the class midpoints, 25 into 275, then midpoint times frequency, x times f, or f times x, 250, 375 up to 1100. And then all you have to do is get the sum of all this. So 250 up to 1100, the total is 6870. And now you'll be able to solve for the mean. So the total frequency n is equal to 50 here. So that is summation of fx over n. So summation of fx is 6850. This one is 6850 over your total n, 50, is equal to 137. So that is your mean. Any questions? All right. Thank you. No questions? And the last part of 3.1 is compute a weighted mean. So this is like how to compute your grades in this class. I'm going to show it to you later. So copy this definition of weighted mean. It is a mean in which some numbers count more than others. To compute a weighted mean, we assign a positive number called a weight to each number, with the numbers that count more getting the larger weights. So the formula is going to be something like this. The weight times the x, the first one, the second after the last one, all over the summation of all the weights. Okay, so let's have an example here. Last semester, Joe took 4 courses. He got an A in statistics, and it has 5 credits. B in psychology, 4 credits. C in English with 3 credits, and an A in music with 2 credits. An A is worth 4 quality points, B is 3, C is worth 2 points. And now we're going to compute for Joe's GPA. So to do that, so the data values are the points for each grade. So we have 4, 3, 2, and 4. The weights are the numbers of the credits. So look at the credits. For A, you have 5. Psychology, for statistics, 5 credits. Psychology, 4. English, you have 3 credits, and music, 2. And the grades with corresponding to the points, statistics, A in statistics, A is worth 4 points. Psychology, B is worth 3 quality points. And then C in English, and a C is 2 points. And music, A, so that's why again it's 4 points. Then divide by the weights. The weights are the credits, 5, 4, 3, and 2, and you will get a GPA of 3.29. Any questions?
May we go back to the formula of this?
Yes.
Thank you. Perfect. Just finding it. Perfect. Okay, got it.
All right. To make it easier to understand this, I'm going to give you an example. Let's say, let's talk about how to compute.
But I'm always working on how I say things, and I might not have it right.
Let's say how to compute your grades here in statistics. So we know that when I explained this during the first day, that your test was 30%. Oh, I think it's 20%, sorry. Oh, it's 30%. Your quizzes, 20%. Your homework is, I think, 25%. Your classwork is 5%. And your final exam is 20%. So you should have a total of 100, 3, 4, 5, 6, 7, 8, 9, 10. So a total of 100%. 20. So let's say, for example, your tests, because you're gonna have 4 tests here. So what you're going to do to compute that, so let's say your first test is 85, the next test is 90, next test is 93, and let's say you get 100 here. So take the average of these 4 and you will have your test grade. So same thing for quizzes. You have 3 quizzes. Add those 3 divided by 3, and then that's going to be your quiz grade. Homework, all the chapters up to, let's say, 14 chapters from your Connect Math, that is 25%. Add those divided by 14, or if there are 13. Classwork, everything about your discussions and your classwork that you submit here, that's going to be 5%. So let's say, for example, pass grade is, let's say you have 84% on the first test. Let's say after your first quiz, you got, let's say, 90. Homework, I expect, since this, I expect all of you to get a good grade here. and I want you to take advantage of this. That's 25% of your grade. So let's say this is 95. And classwork, I expect all of you to answer all the discussions and to submit all the classwork during class time. So let's say 100. Final exam is on the very last day. So how Canvas computes your grade without the final exam? So you can do this every time we finish a test or a quiz. So let's say this is test one, this is quiz one, and this is the average of your, let's say 3 or 4 homeworks. Classwork, let's say the average of all those. So all you have to do here, the weights are this. These are the weights. So 30% times your grade is 84 plus 20% your quiz grade 90 plus homework 25%, and that, let's say you got 95, and plus classwork 0.05 times 100 all over. If you add the weights, these are the weights without the final exam. So 0.30 plus 20 plus 0.25 plus 0.05. So let's try that. 0.3 times 0.84 times 84 is 25.2. This is 18.25 times 95 is 23.75. 0.05 times 100 is equal to 5. Then if you add that, 0.3 plus 0.2 plus 0.25 plus 0.05 is 0.80. So add all that, 25.2 plus 18 plus 23.75 plus 5 is 71.95 divided by 0.8. $89.94. So after, let's say this is after test one and quiz one. So this is your grade so far. Okay. So just in case of you are wondering how Canvas computes your grade, so that is by using the weighted mean. And you can do the same thing if you want to check if it's right or wrong, but it's for sure gonna be correct. Any questions?
Actually, yeah, I'm kind of confused on the how to calculate a part. So I thought we were multiplying at first, so my mind just went somewhere completely different.
Yeah, we multiplied 0.30 times 84 is 25.2.
Oh, I get it. Okay, so then it's 0.20 times 90. Okay.
Yep.
Sorry, didn't see the decimals.
All right, so yeah, because percentages, you have to convert it to decimals all the time. Okay. Any questions? No questions. All right. Okay. So that is 3.1 mean, median, and mode to compute for the mean with the group data and the weighted mean. Okay, I want to show you how are we going to use a TI-84 calculator for this. gonna show the ebook. And where is my calculator?
Hello?
Yes.
Oh, I was just making sure you could hear me.
Yes, Haley. All right. Let me clear my calculator. Sorry. So I'm gonna share. Where is my ebook? Oh, it's on the very last page. So chapter 2, 2.1. So let's say oh 3.1. So sorry. All right, so we have here, can you see my screen? So mobile apps, these are all the apps, and the following table presents the number of monthly users for 15 most popular mobile apps as of June 2015. So monthly users in millions. We're gonna find the mean and the median of this. To do that, using your graphing calculator. So I'm sharing you a calculator here. So all you have to do first is stat1 and enter the data here. So again, stat1 and enter whatever data is given. So I'm gonna type those 15 numbers here. 125.7, 98.9, 95.7, 81.1, 77.4, 76.
I have a question.
Yes.
What did you press to get to that screen that says normal, float, auto, real, radian?
Stat1. Wait, let me finish typing these numbers, and I'll show it to you again. Wait, I'm missing 167 point. All right, so again, so let's say you are on your home screen. So stat, this is the stat here. And then 1.
Got it. Thank you so much.
Then you just have to enter all those numbers. It doesn't have to be in order. So all 15 numbers, enter those. So to get the answers, so I'm going to write it here. To enter data is stat 1 all the time. Okay, and then to get the answers, you have to use stat, arrow to the right, calc, and then 1. So let's do that. Stat, arrow to the right to highlight calc, and then 1. List is that is the table where you enter your data, L1. You don't have to do anything for frequent CList, and then all you have to do is calculate, enter, and look at this. You have the answer here. Mean is the X bar, so 65.98 is the mean. And the median is, you just have to scroll down and look for ME or MED. In the calculator, it says MD. So just copy that. It's going to be 67.9. Okay. That's how you get the mean and the median using a graphing calculator. And also, it's the same shortcuts that you need to use for 3.2 and for 3.1. So 3.2, you're going to see it shortly, is about standard deviation, meaning SX. So this is the standard deviation SX, and that's how you to compute for standard deviation. Okay, and then on 3.3, after you watch the recorded video for 3.3, you're gonna do the same thing for to get all the answers. Start calc 1. When you scroll down here, I'm just showing you. So start calc 1. This is for 3.3. This is what you need. These 5 answers here. The minimum, Q1, the median, Q3, and the maximum. So it's always the same process. Start, arrow to the right, calc 1. Okay. So you will definitely get used to this because we will use this a lot. Any questions? Do we have, there's a question, do we have to buy that calculator? I mentioned that this is a requirement for statistics because it's going to be a lot easier for you to solve all of the problems with a graphing calculator. You can ask, you can borrow any calculators, or I want you to try, where is it this one? So after this class, I want you to try this. Go to your modules, go to your Canvas and click modules. And I want you first to try this. On the very last, you will see a TI-84 Plus calculator here. Can you see it? So click on this, and if you're using Windows or Mac, click on that and try to download it. I don't know what you're gonna see, because during summer it was free for anyone, for everyone. So I want you to do that as soon as possible. Okay. Again, when we started with the lockdown in March, it was for free for all the students for the in the US, and then they decided to do the same thing during summer. So now I don't know this fall semester. So I still have the link, so that's why I provided the link. Please try it. But if not, try to borrow. I know it's expensive, 100 plus. So borrow any TI graphing calculator.
That was under modules and then where again? Oh, materials.
Modules and chapter 3.
Chapter 3. Okay.
So on the very chapter 3 TI, you will see TI-84 plus calculator. Jasmine said you can't open it. Try to click it again. Okay, so all right, so let's proceed to the next one. Let's continue our lecture. 3.2.
Downloading now.
Okay. So yeah, you can do that while we're doing this and let me know, okay? Thank you. All right, so 3.2, measures of spread. So here you will learn about first how to compute the range of data set, and then the variance of the population and sample, and then standard deviation. Also, you'll be able to approximate the standard deviation with grouped data, and then empirical rule, Chebyshev's, and the coefficient of variation. Range is the easiest among all those formulas or statistical treatments that I mentioned. Range is the difference between the largest and the smallest value. So just like an example here, the average monthly temperatures for San Francisco are listed, and just look for the largest and the smallest value. So that is 63 and 51. 63 minus 51 is equal to 12. So that is the range. Although the range is so easy to compute, that's the easiest, like what I said, it is not often used in practice. The reason is the range involves only two values from the data set, that is the largest and the smallest. You might see this on your Connect Math, but definitely I'm not gonna include this on your test. Next, variance is a measure of how far the values in a data set are from the mean on the average. So copy the definition here. So just like an example earlier, so when a data set has a small amount of spread, like the San Francisco temperatures, most of the values will be close to the mean. And when a data set has a larger amount of spread, then definitely those values will be far away from the mean. So again, variance is a measure of how far the values in a data set are from the mean. Earlier, you see when we computed for the mean, we have the sample mean mu, and this is the population mean mu and the sample mean x bar. So for variance, we also have a population variance. This is the symbol, and S squared for sample. Population and sample. So there's a slightly difference between the two when you compute for the variance. So this is the formula for population variance. So summation of xi minus the population mean squared all over n. So again, this is the formula for the population variance. But if you have the graphing calculator, you don't need to memorize the formulas. All you have to do is the shortcut that I showed you earlier, StatCalc1. So like for an example here, compute the population variance. All you have to do is just enter all these 12 numbers. So I'll show you first using the formula. So if you use this formula, first step is you need to solve for the mean, get the average of all these 12 numbers, then xi minus the mean. So meaning you subtract, this is your x1, 51 minus 57.5 is this. Next is your x2, 54 minus 57.5, and so on and so forth. You have to do that 12 times. So 52 minus 57.5 is negative 5.5. That's step number 2. Then step number 3 is you square all those numbers. Negative 6.5 squared up to negative 5.5 squared. And then you get the sum of all these blue numbers, which is 169. And then you will be able now to divide it by the total of numbers, which is you have 12 different temperatures. So 169.12 is equal to 14.083. It's long, right? Do you agree?
Yes.
So that's why I'm going to show you what if we use a graphing calculator. So all you have to do here is, remember when you enter the data, stat1. If you see all this data, so you can just delete all this and then enter those 12 numbers. So I took a picture of those 12 numbers. So enter the date, those 12 is 51, 54, 55, 56, 58, 60, 60, 61, 63, 62, 58, and 52. So L12, L1 12, meaning that's your last number, that's a 12th number. Then again, to get your answers, stat arrow to the right, calc, and then 1. You enter all your data into L1. So then calculate. So you don't see here the variance, but you see here this is a symbol for, remember I showed you earlier, the symbol for variance is this, but you see this 3.752777675. So all you have to do is square this number to get the variance. 3.752777675, square this. What's gonna be the answer? So 3.752777675, square it, and you'll see that the answer is 14.083, and that is what we want. The variance is equal to 14.083. It's a lot easier, right? And you can always do this all the time.
Do we always go 3 decimal points,
Uh,
or does it matter if it's 2 or 3?
I'm not really strict about the decimals, so don't worry.
Okay.
You can either, I just showed you earlier about those, but for your exams, tests, quizzes, final exam, I'm not strict about decimals. But for your
Okay.
Connect, they always they always tell you how many they want. So you will see 4 decimals, 3 decimals, or 2 decimals. Okay.
Okay, thank you.
Yeah, no problem. All right, let's go back to so that's how we computed the variance 14.803. Any questions so far? Sample variance is the same thing, but this time is S squared. You see, I'm just gonna go back and show it to you. So if you do this again, stat calc 1, so that's the shortcut. So you see here SX. So the sample standard deviation is S squared. If the question is find the sample standard deviation, instead of this one, you use this number. 3 is going to be 3.91964,748 squared. You square this and you will get the answer. Okay, so SX is the sample, and this one is the population. So that's why please pay attention to the notations. If you know that shortcut, we don't need this formula. Same thing when you work on your Connect math, so you can just always use your calculator. So next one, Oh, this is an example. Sample variance 346542. Using the shortcuts is the one that I showed you. So start arrow to the right, calc 1, and find the sample variance. So meaning you have to solve for, you'll see on the calculator SX, get that SX, that number, square it, and you will get the answer. Okay, next is compute for the standard deviation. So it's the same thing here. Standard deviation is actually the square root of your sample's variance. Population standard deviation is the square root of your population variance. So just like this, earlier we got a 14.803 when find the population standard deviation. So all you have to do is get the square root of this, and you will have your standard deviation. And that is equal to 3.753. So take note of that 3.753. So I'm gonna show this to you. Sorry if I go back and forth PowerPoint and this. Look at this. This is your population standard deviation, 3.753. So meaning the SX is the sample standard deviation. So when a question is find the sample standard deviation, you have to use SX. If the question is find the population standard deviation, you have to use this, sigma X. Okay, so if you want that step-by-step how to use again the TI-84, you can check the PowerPoint slides. Also, you can check the videos. So we talked earlier about resistant. Just to recall, it is resistant if it's not affected by stream values, and standard deviation is not resistant. So therefore, it is affected by extreme values. Okay, the next one, standard deviation with group data. So remember earlier, we solved for the mean with the group data when I asked you where the class limits, the frequency, you computed for the class midpoints and then multiply F and X. Okay, how about standard deviation with group data? So these are the steps. So I'm just going to show you this to you. So given 50 high school students here, you have the frequency distribution table, CF, and then class limits, and then the frequency. First, you have to get the midpoints, just like what we did earlier. you know how to do this. Then midpoint minus the mean. X minus the mean. This is a lot. Then f times x minus the mean squared. So meaning you multiply this 10 times the square root of this, 5 times the square root of this to get this, 13 times the square root of this to get 1872, and so on and so forth. And then you're going to get the summation of all these numbers to compute for the standard deviation. So when you add all these numbers, it's 292,800. And you divide by n minus 1 and square root it to get the final answer. So meaning this, the formula for standard deviation summation of square root of summation of f times x minus the mean squared all over n minus 1. Oops. All right, so of course we want the shortcut for this, right?
Most definitely.
So this is okay, let me erase this formula. All right, so where is my, sorry. So instead of doing all those, so what we need actually is only, wait, where's the table? Okay, so if you go back on the very first slide, the given, so you have the f and the class midpoints x. What's the first class midpoint again? 50 plus 0 divided by 2 is 25, 75, 125, 175, 225, and 275. So we just need to enter all these numbers into our calculator. Okay, I'll show it to you. So get a graphing calculator. So let's say go to the home screen. So stat 1, that is where you enter the data. So if you have these numbers, you can delete all this. First, you need to enter your class midpoint. You have 25, 75, 25, 75. What else? 125, 125. Wait, I took a picture. 125, 75, 125, 175, 225, and 275. And then what are your L2? That is 10, 5, 13, 11, 7, and 4. So next is and is it 4? Yeah, 4. So again, don't forget that this is your X and this is your class midpoint and class and your frequency F. So start calc.
Are you working from a certain problem or page in the book?
No. I think this is the same problem if you check the book.
Oh, okay, so you was just entering the frequency in L2, right?
Yes, yeah. So it says
Okay.
enter the midpoint into L1 and then frequencies into L2.
Okay.
Okay. Then select one var stats L1 and L2. So stat calc 1, just like what we did earlier. L1, oh, this one. Frequency list is this. You have to enter here L2.
Okay.
To enter L2, that is second 2. Okay.
Okay.
Second 2 is L2, and then calculate, you will get the answer.
Okay.
So earlier, the group mean is 137, and this is the standard deviation 77.3. Okay.
Okay.
So again, make sure that you enter L1 is your X, meaning the class midpoints, and then the frequencies into L2, and then stat calc 1, L1, and frequency list is L2. Okay. Calculate, you will get this. But don't forget, when you are working on something else, let's say if you just enter a new data, and if you just want to solve for mean and median, stat calc 1, don't forget to delete this. Okay, you only enter that L2 when you are working on a group data.
Okay.
Because if you have something there, the frequency list, if you have L2 there, all of your answers for the other problems will be incorrect. Okay, so don't forget to remove that L2.
I have a question.
Yes.
When you're typing information like into L1 and you like type a wrong number, how do you delete the single number?
I don't know if there is backspace. You can just delete the whole number.
So you just have to start over?
No, no. Just one. Just the delete. Either the delete on your laptop or the delete button on the calculator.
I just found it. Thank you so much.
Oh, you found it. Okay. Yes. There's one. The delete here. So the red one that is.
Yeah, I have a used one, so some of the stuff is kind of worn away, so I'm kind of guessing what it says.
Okay. Yeah. All right. Let's continue this. So here you can see that we have the answer, exactly the same thing, 77.30. So next objective is the empirical rule. So earlier I showed you a bell-shaped curve, and I mentioned that if mean and median are equal, then it is symmetric. It's gonna look like this. Many histograms have a single mode near the center of the data and are approximately symmetric. And also I showed this an example like this when we talk about histograms. Do you remember that? So this is a bell-shaped curve. So there is actually a whole chapter about this, which is chapter 7. But for this part of chapter 3 or 3.2, we're just gonna talk 3 things, which is the empirical rule. So that is when it is 68%, meaning it's the data will be 1 standard deviation of the mean. So remember the center is the mean. 1 standard deviation away is you subtract and you add that 1 standard deviation from the mean, and the total is 68%. When you subtract 2 standard deviations away from the mean, or you add 2 standard deviations away from the mean, the total of that is 95%. And the last one, when you subtract 3 standard deviations or you add 3 standard deviations away from the mean, the total is, for now, it's almost all, but it's actually 99.7%. It's almost 100%. Okay, so for empirical rule, for this time, for this chapter, you only need to memorize 3 things. 68%, that's a total 1 standard deviation away from the mean. 95%, 2 standard deviations away from the mean, and almost all 3 standard deviations away from the mean. Okay, so let's say an example here. So the following table presents the U.S. Census Bureau projection for the percentage of the population ages 65 and over for each state of the District of Columbia. Use the empirical rule to describe the data. So when you compute first for the mean and standard deviation, so all you have to do is enter all this data, stat calc 1, and you will get the mean and standard deviation. That's the first thing you're going to do. So what is the mean, so that you know the center of your data? So this is the histogram. So the center is the mean, which is 13.25. Standard deviation is 1.68.3. So by empirical rule, If you compute the standard deviations away from the mean, mu minus the standard deviation and mu plus standard deviation, and that is 68%. So again, when you compute for the mean, what was the mean again? 13.25. So this is 13.25. So 68%. What are the numbers here? 13.25 minus the standard deviation. This is the standard deviation 1.6827 is 11.57. Mean plus standard deviation is 14.93. So between 11.57 and 14.93, this is 68. Okay? And if you want to get 95%, all you have to do is compute for mean minus 2 times your standard deviation and mean plus 2 times your standard deviation. So after you solve that, you will be able to get 95%. So like, so 95% is 9.88. So let's see, 1, 2, 1, 2. So 2 standard deviations away from the mean. 2 standard deviations. Sorry. Computed, that is 9.88, and this is 16.61. So from 9.88 to 16.61, this is 95%. Any questions? So that is the empirical rule. Only 3 things, 68%, 95%, and 3 standard deviations away from the mean. Sorry. All right, next one is Chebyshev's. So this is very similar to empirical rule. So when a distribution is a bell shape, we use empirical rule to approximate the proportion of data within 1 or 2 standard deviations. Another rule called Chebyshev's inequality holds for any data set. So again, we only use empirical rule if we have a bell-shaped curve. So for any data set, we can use Chebyshev's inequality. So what is Chebyshev's? So the formula is 1 minus 1 over k squared. So again, take note of this, 1 minus 1 over k squared. So let's say if your k is equal to 2, just substitute 2 here. So 1 minus 1 over 2 squared. 2 squared is 4. 1 minus 1/4 is 3/4. So that's why you have here 3/4 is 75%. K is equal to 2, meaning 2 within 2 standard deviations of the mean. Next is if it's 3, 1 minus 1 over 3 squared. 1 over 3 squared is 1 over 9, and 1 over 9 is 8/9. Or 8 divided by 9 is 89%. That is the data that's within 3 standard deviations of the mean. So that's why, again, just memorize this. 1 minus 1 over k squared. Or just memorize when k is equal to 2, meaning that's 75%. When k is equal to 3, that is 89%. earlier we have 2 is 68%, 3 is 1 is 68%, 2 is 95%, and almost all it is 3. Okay, an example here. As part of a public health study, systolic blood pressure was measured for a large group of people. The mean was 120 and the standard deviation was 10. So how are we going to use Chebyshev's inequality here? Wait, so the chat. Well, I can see the chat. So Chebyshev's, remember we have k is equal to 2 and k is equal to 3. Right? So when k is equal to 2, we computed that it is 75%. When k is equal to 3, we computed that it is 89%. So we're going to compute standard deviation away from the mean. So just like what we use for empirical rule. So compute for x minus 2 times the standard deviation and x minus 3 times the standard deviation. And here, 120 is the mean, minus 2 times 10, 20 is 100 and 140. 3 times 10 is 30. Subtract it from 120 is 90, 90 and 150. So how are we going to interpret this? So the first one, at k is equal to 2, at least 75% had systolic blood pressures between 100 and 140. When k is equal to 3, at least 89% had systolic blood pressures between 90 and 150. Okay, please copy. Any questions? Sorry, this is the long section. I think this is the longest section in all the chapters. And the very last objective, coefficient of variation. All right, the last one, coefficient of variation, copy the formula. There's no shortcut for this, but it's just only the standard deviation over the population mean. So CV, or coefficient of variation, tells how large the standard deviation is relative to the mean. So again, standard deviation over the mean. So an example here, the National Weather Service records showed that over a 30-year period, the annual precipitation in Atlanta, Georgia had a mean of 49.8 inches with a standard deviation of 7.6. And the annual temperature had a mean of 62.2 degrees Fahrenheit with a standard deviation of 1.3. So compute the CV, or the coefficient of variation, for precipitation and for temperature. And answer the question, which has the greater spread relative to its mean? So precipitation, so we have it here. Standard deviation is 7.6 over the mean 49.8. When you divide that is 0.15. Then for temperature, given the mean 62.2 and the standard deviation of 1.3, 1.3 divided by 62.2 is 0.02. So comparing the two, the coefficient variance for precipitation is larger than the coefficient variation for temperature. So therefore, it has greater spread relative to its mean, the precipitation. Okay, copy. That is for CV, coefficient of variation. And this is the end of 3.2.